Welcome everyone. In this video lecture, we will draw the stick diagram of a two input CMOS NAND gate. So I have already made the two input CMOS NAND gate. So basically a two input CMOS NAND gate uses two PMOS, okay, and two NMOS like this. So I'm not discussing the structure, so it is very simple. Okay, so this one is our P1 transistor. I'm saying this one is our P2, and this one is our NMOS N1 and NMOS N2. Okay, so these are the two PMOS, two NMOS, and we are taking output here. So one more thing, this in is our source of 1, source of 2. Okay, or we can better to write source of P1, source of P1 terminal, arrow sign source terminal, S of P2. Okay, this one is our gate of PMOS. So P1 I am writing, gate of P2. Okay, and this drain of P1 and drain of P2. Okay, we can write similarly the source terminal. This one is our source terminal, arrow sign means source terminal, source of N1. Okay, this one is simply our gate of N1, and this one is our what, source, gate, and drain of N2. So drain of N2 and these two are common, and source, and this one is our drain of N1, and this one is our source of N2. Okay, and this one is our gate of N2 transistor. So this is very simple. So why I have written, it will clear very soon. So first of all, we have to draw the what, VDD line and ground line in a stick diagram. So it consists of a blue color. Okay, so I am just, in my earlier video I have already given the theory behind this. So okay, so I will also put that one in the description link. So this one is our VDD line, so which is a blue color line. So this should be VDD, and this should be ground line, or sometimes it can be say VSS line. Now two PMOS is there. So for PMOS I am making here for PMOS. Okay, for PMOS representation, what we have to do, we have to take the one yellow color line for the P plus diffusion. Okay, and one red color. So this one is our yellow, one is our P plus diffusion. Okay, and this red one we know, very simple, polysilicon line. Okay, silicon. So this one is our gate. Okay, so what basically this will be our gate of P terminal. Okay, and now this side means either this side will be drain of P or source of P, or this side will be our source of P or drain of P. Means it may be either drain of P or source of P, or it may be our source of P, any one. Okay, means like that, simply we can say it may be either drain or source. Okay, this similarly for the NMOS. Okay, in stick diagram, the NMOS, the NMOS consists of a green line. Okay, as a P plus diffusion, sorry, N plus diffusion, and a red line. So this one is our polysilicon. Okay, polysilicon. Okay, and this green one is our N plus diffusion. Okay, line. So basically this will be our gate of N terminal, and it may be our source or drain, source of N or drain of N, and if the above, if we make it drain, then it should be source, like that. Okay, source in, drain in. Okay, so here we can easily see there are two PMOS. So I am making two PMOS. Okay, so for PMOS what I am doing, two yellow line I am just making two yellow line like this. Okay, and then two polysilicon line like this. Okay, so this one may we can say the input we are giving A, so we are saying B, and these two may be our source. So if I am saying this one is source, so now to connect this one, okay, either directly this one is connected to the source, one is connected to VDD, so the yellow line directly you can connect to the, okay, here also the source of PMOS is directly connected to the supply. Okay, and then we have to make it contact, so make it contact here. Okay, now this one is over. So what I am saying, this one is our source of P1, we can say source of P2. A is nothing but simply our gate of P1, and B is nothing but simply gate of P2. Okay, now next these two is connected. So what we can do, directly this drain side is connected like this. Okay, so this one is our, we can say, drain of P1 or drain of P2. Okay, clear? Then after this part is over, now two NMOS is there. So for NMOS, what we can do, we can make like this. Okay, two NMOS we have to make. So I am making like this. Okay, so and this NMOS one is correct like this. Okay, so first make two NMOS. So this one is our, again we can write as A and B. Okay, or you can write just like this, like B and A. Then after these two are connected through a metal line, or directly we can connect, and if you are connecting with some metal line, better to connect it metal line. Okay, so these two are connected through say metal line. Okay, and one output is coming from this side, so make this as a B output, nothing but simply AB bar. Okay, now this is nothing but simply, this B is what, our gate of N1 transistor, and this one is our gate of N2. So above this we can say this one is drain of N2. So I am writing, and this one is our source of N2. For it, a source of N2. Now these two are connected. Okay. So what we can do? This two, this one is nothing but simply our, write it, source of N1, and this one is drain of N1 is connected together. So you can directly connect this one with a red color. So this one is the connection. Okay, and we have to make a contact here. In PMOS and NMOS, there should be no, means, black dot. Okay, so like that, this one we have connected. So this one is a B, two NMOS. Okay, so this one is source terminal, drain terminal, gate terminal, source terminal of, okay, it should be drain of N2. So this should be drain of N2, no? Drain of N2. Okay, clear? And it should be drain of N1. Okay, so like that we can easily make like this. Or if you have to make this one, again what we are doing, this is the overall representation. After some time, after you become, when you become expert in this one, what you have to draw like this. Okay, this would be our VDD ground. Okay, so make it VDD and ground with blue color. Now we have to make two PMOS. Okay, so for PMOS, what we are doing like this. Okay, so two PMOS. Okay, clear? This one is two PMOS. Okay, the two PMOS is connected here. Their drain terminal are connected. So I have already connected the drain terminal. Okay, so connect it. Okay, next there is two NMOS, N1 and 2. Okay, for N1 and 2, what we have to do? 1, 2, 2. Okay, N plus diffusion A and B. So you can write it A, B, then it should be A and B. Now these two are connected. These two A and B source and this drain is connected. So better to connect with the same color so there is no dot or something. Okay. Now these two, in between these two, we have to take the output. So what we can do, we can connect with some metal line. Okay. So there will be one black dot here, one black dot here. Then after blue line. So blue line. So no need to connect. This one is V output. That is our simply AB bar. Okay. And then we have to make contact. So it should be dot here, dot here, dot here. So like that we can do. So here we can also once again I can say this one is gate of P, this one is also gate of P. Okay, and it is source terminal, source of P1. Okay, what we have written, we can write SP1, GP1, and this should be GP2, SP2, DP1, drain of P2 most. Then this one is a source of N2. This one is N2 transistor. So source of N2. This one is B1. Okay, B or A, anything you can. So it should be our G of what? N2. Gate of N2. Gate of N1. And these two are connected. So source of N1 and drain of N2 are connected. So like this. So now, and this end is nothing but simply this one is our drain. So drain of N2. So drain of N2 and this their drain is connected together. So like this. So this is the overall stick diagram. So very simple, means for the NMOS we have to know the how to make the NMOS. Simple, green line, and then some red line. Okay, this one is our NMOS. Once again I am writing for PMOS, this one, and this one is PMOS. Okay, and if you want to draw the demarcation line in between these two, demarcation line with the brown color, demarcation line. Okay, so this is all about the simple representation of a stick diagram. The detail is already given in my last video of this stick diagram theory. Okay, and the other application, everything is given. So this is all about this simple stick diagram of a two input CMOS NAND gate. So thank you for watching this video.